we're given a series, asked to write out the first 5 terms of the series, and then asked to figure out whether it converges or diverges. Now, if you've seen enough examples, you might be able to look at this summation and know right away what kind of series it is. But for the rest of us who might not have seen enough examples as of yet, maybe we'll know what kind of series it is after we've written out the first so many terms. And that'll give us the ability to tell whether it converges or diverges. So I'm going to hop right in and starting at n equals 0, evaluate the first 5 terms. Well, when I plug in a 0 on top, I get a 2. On the bottom, I get a 1, so I just get out a 2. Next up, I plug in a 1 on top, I'll get 4, and on the bottom, I'll get 5. Plus, now 0, 1, the second spot here, starting counting at 0. Let's see, that's going to be 2 to the third is 8 over 25. 0, 1, 2, 3. Plug in that, and I will get a 16 out of 125 plus 2 to the 5th is 32 over 625 plus ... going on forever and ever and ever. All right, well, looking at these values, I think I know exactly what's happening. We're starting at a 2. To get from 2 to 4/5, well, I've multiplied by 2/5. To get to the next term, I've multiplied by 2/5 again. This seems to be geometric with a first term of 2 and an r of 2/5. Every subsequent term is 2/5 of the previous term. I'm always multiplying by 2/5. Well, geometric series can be written down in this format, and they always converge to a over 1 minus r when r is between -1 and +1. Well, r's 2/5. This is a convergent geometric series. That's 2 over 1 minus 2/5. Let's see, that is 2 over 3/5, which is 10/3. This geometric series converges to 10/3. All right, well, looking at this, I know it's geometric. Looking at my definition of a geometric sequence, that isn't quite in the right format. It's one of those geometric series always have the property of starting somewhere and generating each next term by multiplication. So this can be written like this. So just in case you were curious, I can write this this series down in that format. I'm going to start by writing it as 2 times 2 to the n over 5 to the n. Right, because 2 to the n plus 1 is the same thing as 2 to the n times 2, and I can just write that 2 out front. That lets me write the inside of this summation as 2 times 2/5 to the n. And now we're looking really close to this, and I realize that to really write it down like this, I have to re-index my sum. I want the sum to start at 1 and go to infinity, which means I need to take 2 away. So 2 away, I need to take 1 away from this exponent, because I'm starting at 1 later than it used to work. And so there's 2 times 2/5 to the n minus 1, a and r, fitting right in where they go. There's no need to go through all this work if you don't want to. We can find a and r just by seeing the first term and the value we're multiplying by to get the next subsequent term of the series. And that's it.